Answer how many intersection points on 10 lines, maximum intersection points on 10 lines. Come to the board, show us what they got and how they got it. Who feels semi-comfortable? You don't even have to feel comfortable. Okay? As the song goes, one step enough. You don't need to know everything. Okay? Please.
The
Number of intersection points. Okay?
So, I kind of did it like, I don't know if someone came to the board the other day, but I just started with one line. It doesn't have any. And then with 2 lines, it can only have 1. And then with 3 lines, it can have 1, 2, 3. And then with 4 lines, 1, 2, 3, 4, 5. And if you look at this, you can just see a pattern kind of happening. That this one is just that. This one are those 2 added together. This one are those ones added together. So just the previous numbers added together. And so if you kept that going, then 10 lines would have to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, which is 45, yeah. And she said 45 last time, so she got
So
it.
you believe what she said then?
I believe her. Yes.
And you're willing to bet $100 that that's the right answer?
I did bring $100.
You did bring it. Whoa.
No. Well, no, I didn't. I don't have that
Okay.
kind of money.
Who, yes,
On that one, I did it a different way.
please.
6, well, just for like that fourth one with 5 lines,
Yeah.
4 lines.
She just wrote the wrong number. She meant
Oh,
6. Yeah.
Oh,
For
okay.
4, there's
3,
6
4, 5.
intersections. If you keep the
Okay,
line,
never mind.
your 4th line going, you'll get
She said add 1 plus 2 plus 3, and that's,
Oh, 6. Yeah, sorry.
that illustrates the difference between arithmetic and mathematics. How many times do students have the does she know any mathematics?
Oh, yeah.
Is her mathematics pretty good? So we can overlook a little arithmetic error, right? But in the elementary grades particularly, and even in the junior high and high school, when students make an arithmetic error, the teacher just goes crazy and can't stand it because that teacher believes that what's important is the answer and that you have to be flawless in your arithmetic facts, when in fact, she knows what she's doing. She explained it. She said add this, this, and this. That's the right thing. To me, that's more important than knowing that 1 plus 2 plus 3 is 6. You understand what I'm saying? Don't sell your students when they make arithmetic errors. Don't interpret that to mean they're not good at mathematics.
So I kind of did it a similar way, but I ended up like setting up how I would get to the 45.
Come show us, please.
Try it. So I looked at it and said, well, if you add 2 and 3, or if you do 2 times 3, so okay, let's start. We're gonna look for what this number is. So we've got that we're on 3. So you're gonna do 3 times and then n minus 1. This is how I set it up. 2 divided by 2. 3 times 2 is 6 divided by 2 equals 3. So that's gonna be that 3. If you did for the 4, we're looking for this number, then you do, what my process was is I did n times n minus 1, where n is this number, and I then divided all of that by 2.
Okay, why did you do that?
Because I saw the pattern.
You did?
Yes.
N times n minus 1 all over 2 jumped right out at you?
Well, I did a couple of these, and so I figured out what the intersections would be first, like she did. But then I looked at what the pattern would be.
What do you mean you looked at the intersections?
I did the same thing she did. I just drew it out
Mhm.
first until I got to about 4, and then I started trying to figure out what the pattern would be. I just didn't think of the 1 plus 2.
So this here came from number patterns?
Mhm.
Can anybody explain where else it might come from besides number patterns?
Where formula would come from?
Yeah.
That's also the summation of any amount of numbers starting from 1 to n.
How do you know that?
Because I took calculus.
Okay.
That's what they told me.
Okay. All right. Well, there's somebody with a little bit more background. I'm trying to see if anybody can see any. Can you see the geometry here? Kim, is it Kim? I think you were on to something. Can you tell us what that formula means? Get up here. And let's see, who's just up here?
Rachel,
Rachel.
call.
Call.
Okay, so she has good pictures, but, so if, for the first one, the n represents, you know, how many lines you have. And, you know, well, maybe the second one would be better. So if you had 2 lines, then they can only cross at 1 point. So the next line you add can only cross the number of lines that you already had. That way. So when you make that 10th line, it's going to cross all 9 of the other lines and create 9 more points.
Who wants to ask a question? Yes.
So why would you divide that by 2?
You would divide by 2 because for every line, only 1 point is created. So while you have 2 lines here, only 1 point was created.
Can you do an example on the board?
Yeah.
Explaining that?
You're like way above the rest of us.
Back down to elementary.
I think I know why we do it for the summation formula for like y, because I'm trying to figure out how to word it right. Because if I had wanted to sum up the numbers from 1 to 10, and I'm doing 1 plus 10, 2 plus 8, 3 plus, anyways, they all end up being 11s, but once I hit that midpoint, when I'm past, I'm doubling up on numbers that I've already got. And so the n times n minus 1 will cover all of those, and then we'll divide it by 2 and take out the half that's copying.
Raise your hand if you followed that. Ooh, something, whoa, I'm impressed. Okay, yeah, but
Is that the equation for like factorial? No. Factorials? No, something else. What's the term?
not factorials. This is for sum. Factorial is
Yeah.
multiplication.
I can't remember the term.
It'd be 1 times 2 times 3 to whatever the number is factorial. Can you,
I can't remember.
I'm trying to think how to explain it differently.
let me try it.
More like a geometry.
Let me try it. When I have 1, there are none, right? 0. 2, when I draw that second line, it can only cross 1 line because that's all that's there, right? If I draw a third line and I don't want it to be parallel to any, that means it will intersect both. So I will get 2. So I'm going to have 1 plus 2, right? Then when I draw this one, it will be plus, whoops, 3. They don't make chocolate like they used to. Plus 3. Now there are how many lines?
6.
How many lines?
4.
4. So when I draw my next one, it will cross all 4. So we'll add 4. Do you see why we're adding 1 plus 2 plus? All right, so now here is the question. If you'll notice, this line has how many intersection points on it? 3. Look at this line right here. How many intersection points does it have on it? 3. How many does this one have? How many does this one have? So I could get the total by saying I have 4 lines, and they each have 3 intersection points. 4 times 3. I should have 12 intersection points, right?
Except you're doubling up on your intersection.
What? It's really what?
6.
Well, then how did I get, I mean, doesn't that make sense that it should be 12 if there are 4 lines and they each have 3?
They share intersection.
Ah, when this one crossed that one, I counted it for this line, and then I counted it again for that line. So I've counted each point twice. That's why we do this. So the number of lines, that's the n, times this will always be, the number of times it gets crossed, it will be crossed by the other 3. The line can't cross itself, so it's always one less than itself that crosses it. Does that make sense? Divided by 2 because you don't want to double count them. Does that make sense? Okay. I need somebody to go to the board for the back side, the part B, the regions. Somebody who felt like they got it. Nobody got it? Did anybody engage with it? Did you get it?
I'm pretty sure I got it.
Okay, go to the sideboard there.
It's messy. So do you want me to like draw the circle? Or?
I want you to tell us what you think the did you finish filling out the question marks?
Yeah.
Okay, tell us what you got and how you got it.
Okay, so the pattern that I was looking at is the number of regions created doubles every time that you create another point. I was trying to figure out exactly why it doubles. But
Did everybody hear what he said? He was trying to figure out why. We know why this does this because we've got this formula and we have proven that this will work because this makes sense. The number of lines times the number of lines that cross that line divided by 2 to not double count, okay? So he wants to explain why, he says.
Well, that's what
Share us what you got, and then we'll go from there.
So I ended up just starting with the 5 points. Sorry. It really doesn't matter where they are. It will end up being the same. You don't want it centered since you can only have the intersection, 2 lines intersecting in a single point. So
Because we're trying to maximize the number of regions again, right?
yeah. So I ended up just going from 1 point and doing all of its points. Let's see, that one's already got there, that one's there, that one's there, and that one leaves that one. It's kind of interesting, it makes a little star and pentagon. But I ended up getting 16 different sections created.
Would you just count, just touch a dot in each one so that we can see if that's really true?
So we got 1.
Don't number them, just a dot. I want to save that for later.
All right.
One.
So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Has he convinced you that 16 is the answer? Did anybody get more than 16? Okay. So you put a 16 under the 5.
And then we're looking for the 6.
Okay.
And so I ended up doing the 6 to confirm it, but I just looked back at it and I was like, okay, 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2 is 16. So I'd already guessed.
That
All right,
it's-
it's probably going to be 32. And if you want, I can draw it out. It'll take a minute, but we can do it.
How many of you got 32 for this? How many? Raise your hands if you got it. Keep your hand up if you're willing to bet $100 that that's the answer.
Double or nothing?
Double or nothing? Oh, he's gonna, so if he wins, I pay him 100. If he loses, he pays me,
What? No,
200?
no, we're doubling.
what?
We're doubling the stakes, right?
Oh, you wanna go $200, either way.
Why
Show
not
us.
500?
Show us.
Because I'm not that rich.
I don't have 200.
I'm making this big because it's
Because it needs to be big, right? Those of you who tried it.
two,
How many of you tried it? How many of you got 32? Oh, you tried it, but you did.
I tried and I got
I did too.
I was confused on the wording, because I thought that no two lines could have two intersections, and so I thought,
just did a single point.
yeah, and so I was just a little confused. But
You
then-
don't want more than 2 lines going together at the same point.
Right, but I interpreted it as no line could have more than, because in the diagram, each line only goes through one once. So each line only has one intersection in the circle, and so that's why I was just a little confused with this.
So if you have a different interpretation of the problem, you might end up with a different
Yeah, so.
answer that's correct
Right,
according to your interpretation.
right.
That's another thing teachers do. Well, you didn't get my right interpretation, so you're going to miss this whole thing. No, listen to what they had thought it was and follow their logic out. And if their logic is right for the way they understood it, then guess what? They know math, right?
Right.
Math is not just about getting answers. Okay? Number them this time.
Okay. 1, 2, 3, 4, 5, 6. Let's see. 7, 8, 9, 10, 11, 12, 13, 14.
Got some little teeny regions here.
16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now I'm feeling bad. I'm missing one.
Every time I did it, I was missing one. I just did it again and I was missing one.
If your line
Has he got lines that aren't straight?
Did
Did he do something wrong?
you get that one, that
Did
little
you get the
teeny
really
one?
little tiny
This
one?
one right there?
Yeah.
That's number 12.
Good. Way to keep your eyes open. Have we got a mistake here? I should have brought my $100 today. People, I've led you down a primrose path. It is 31. And I don't care how hard you try, you're not going to get 32. And why did I do this? I set you up where a pattern, up 1, up 2, up 3, up 4, whatever, and the pattern holds true. And why does the pattern hold true? Because the geometry tells us it's true. The number of lines that I draw, no matter how many lines I have up there, when I draw that nth line, it can only cross one less than what's up there, right? And then I divide by, does everybody understand that logic there? Now, once we have that and we understand the geometry behind it, we can say we know with certainty, this is betting stuff, that we're going to get this many. 45 for 10, just stick 10 in there. 10 times 9, we get 90 divided by 2 is 45, right? But is there any geometry? Inductively, that's the difference between, you need these two words. Inductive and deductive reasoning. Two kinds of reasoning. This one says, look at a whole bunch of examples and draw a conclusion. Many of you did that. Many of you looked at this and said, oh, up 2, up 3, up 1, up 2, up 3, so I'm just going to go up 4, up 5, and I'm going to keep going until I get to number 10. That's using the pattern of reasoning, okay? And many of you did it over here. You said 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So 8 times 2 must be 16. And it turns out that it really is 16. We've got proof right there. But, so following that pattern inductively, we would what? We would guess that it's 32. But we have no geometric. Can you see why it should be doubling? Is there an explanation for it? Is there something? No. You can never prove anything inductively. You can strengthen your argument, and the more time, the more cases where it's true, the stronger your argument gets. You have a stronger argument after you get to 16 than you did after the 8. But guess what? All it takes is one single counterexample to shoot you out of the water, and the whole thing falls to pieces. Okay? That becomes important through the rest of the semester. So what's deductive? If this is looking at examples and seeing patterns, what's this? Yes?
You have a conclusion and then you make some little facts off of that conclusion. So you go big, oh no.
You start with some given things that you accept. Do you accept the fact that when 2 lines cross, there's one intersection point? If you accept that, then I will say, all right, will you accept the fact that if I want to maximize this, I can't have any parallels, right? Therefore, the 3rd line I cross will what? Will intersect everything that's there. How many does it intersect? Well, if there's 3, if I'm putting the 3rd line, it will intersect 2, because it'll always intersect 1 less than what's up there, because it can't intersect with itself because lines don't curve. Does that make sense? Do you accept that? Then we'll go on to say then, if that's the case, you'll notice that every single line has 2 intersection points less than the number of lines. Why? Because it has to cross the ones that were there when you drew it, right? And if that's the case, it'll be 2 less. So you take the number of lines times the number of intersection points. That should be the total, right? Except for one thing. What? We double count. So we have to divide that by 2. Now we have logically worked our way through the point. Now we know that it's true. Okay? Okay. We've got to hurry because we've got lots to do today. Questions about the vocabulary? Anybody have a vocabulary word that they want to ask about?
Can you explain skew lines?
Skew.
Just a bit more?
Can I borrow your pencil? Can I borrow your pen? These 2 lines are parallel. These 2 are intersecting. These 2, are they parallel? Are they intersecting?
No.
So how might we define skew lines?
They don't share.
2 lines that aren't parallel and they're not intersecting. And some of you are going, well, how's that possible? Well, how is it possible?
They're on different planes.
They're not in the same plane. Meaning that if this one's in this tabletop here, this one has got to be somewhere else. Right? Does that help?
Yeah, I kind of have the concept that I just know.
Okay. Let's see.
Yeah.
I thought it takes 2 distinct lines to determine a plane. So if there's one on one plane and one on the other, how does that?
If there's this one and this one, they don't determine a plane because 2 parallel lines or 2 intersecting lines determine a plane, but not 2 skew lines. Good question. Anybody else on the vocabulary? Yes.
In the picture, they're crossing.
Where?
Skew lines. That's what we're talking about, right?
Yeah. Can you see my 2 hands? Do they appear to be crossing from where you're at? Do they appear to be crossing from where you're at? I'm drawing on a 2-dimension sheet and I'm trying to show you 3-dimension. So it's hard to do. So I've tried to give it some perspective, but does that make sense?
Yeah. That
Okay.
is definitely-
Does everybody understand the problem that that can bring when you're trying to draw 3-dimension?
Oh, never mind.
Okay?
I was gonna be helpful and then it wasn't helpful. I was gonna say there's no like point of intersection that's labeled, but I guess you don't always label a point of intersection.
Well, if there is none, how are you going to label
Well,
it?
but so if there is a point of intersection, it's always labeled.
You could.
Okay.
You don't have to
Oh.
label it.
I was gonna say it's not labeled, so that's how
No.
you know there's skew.
No, you don't have to label it just because they do or don't. Yeah. That's the vocabulary. Questions about the, go sit that down in the back of the room and hand all these out.
Yeah.
Or hand one out for every person. We're going to learn some alternative methods for constructing. We've learned to use our traditional tools, the straight edge and the compass. Today we're going to learn to use patty paper, and we're going to learn to use a mirror to do constructions. Patty paper comes from the fact that when you make hamburgers and you're pattying them up, you don't want the beef to stick together. So you insert a patty paper in between. These are actually ground beef, patty paper, right here, look at this. And you can buy them from any restaurant distributor. However, if you're at home and you don't have any of these, wax paper works wonderful. These are impregnated, you can kind of feel it, they're impregnated a little bit with wax. And the reason for that, you'll see in just a moment, is when you crease this material, it causes a line to show up, a visible line that doesn't go away, all right? That's what you need in order to do this. So any kind of paper that will do that will work. So, if I were to ask you to copy a segment, remember that one? So you've got a segment on your paper, and I give you this, and I ask you to copy it, what would you do? Put it over top and trace it. Yep, that's right, that's how we do it. If I said copy an angle, same thing. Put it over top of the angle, trace it. Now I've got 2 exact copies, right? All right. What I'd like you to do is, with your straight edge and your pencil, draw a segment about approximately 2 to 3 inches long on your patty paper. Yeah, put it up near one edge. We can use this for more than one diagram and save some patty paper here. A pen is fine. Yep, a pen is fine. Everybody got a segment drawn? Sure. Now what I'd like you to do is put your pen or your pencil down, pick up your patty paper, now using just your patty paper and your brain, your hands, the patty paper and your brain, I would like you to construct. Now I'm putting it in quotes because construct means, when we say construct in this geometry class, we mean use your straight edge and compass. Okay? So this is a quote construct. The perpendicular bisector of this segment. Just put, don't touch it with your ruler, your straight edge, your compass, just your hands, your brain, and think about it. Now, how are you going to construct the perpendicular bisector of that? If you figure it out and your partner's having trouble, don't jump in real fast, but maybe give them a hint or something that you could.
Like you do the first one, but then you don't have to get so much. Then
Raise your hand if you have figured out how to make a perpendicular bisector with just your brain, your hands, and your... Okay, it's coming along. Okay. I need somebody who couldn't figure it out on their own and took a hint from their neighbor. I'd like them to explain to us in their own words how to do it. Okay?
Well, my neighbor told me to fold it over so the 2 points overlap each other.
So the two endpoints of the segment are touching each other, right on top of each other, and then what? Make a crease.
Yeah.
Make sense? Is that how all of you did it? All right. Down near the middle, take your straight edge and make me an acute angle. An acute angle.
Do you want us to work off the one we already have?
No, just come make a whole new, don't work off the segment you've already got. Just make two new rays, joining together at the vertex, and an angle. As soon as you've done that, what I would like you to do is pick up your patty paper, put your pencil down, put your straight edge down, put your compass down. The only thing you can use, the rules with patty paper is brain, hands, and paper, and that's all you get to use. Can you construct the angle bisector of that angle you just drew? Okay? Again, if you're really struggling, get a hint from a neighbor. Raise your hand if you've got the angle bisector. Let's hear from somebody who maybe needed a hint. You want to try it?
Okay, so we kind of did the same thing that we did for this one, where we just folded the angle in half so that...
Folded the angle in half. Here it is. Did you fold it this way?
No.
I mean, fold it. Okay, so that the lines were on top of each other. Okay? And as long as the two lines were on top of each other, did it? And then what did you do? You always have to crease it. Now, on a test, and by the way, when I give my test down in the testing center, you pick up your test, you pick up your patty paper, and then you staple it on the end. How do I know what you did? I can see your crease. Okay? All right? Does that make sense? Okay. Get your second piece of patty paper. The clean one. Does everybody get a clean one? Okay? And what I'd like you to do is with your straight edge now make a line that goes all the way across. Or pretty much all the way across. It doesn't have to be parallel with one of the sides. It can be any direction you want, any angle. Just a big long line that goes across the... Alright? Now with your pencil, move about 1 inch to 2 inches, somewhere in there, off of one side or the other. Doesn't matter where. It doesn't have to be center or anywhere, but you don't even have to measure. Just eyeball it 1 inch or 2 away from the point, and put a point 1 inch or 2 away from the line on one side or the other. Okay? So your point is not on the line. It's about 1 inch or 2 away from it. Right? Like this. Now, put your stuff down. Pick up your patty paper. And what I'd like you to do is make the perpendicular bisector that's perpendicular to the line you drew, or not bisector, I said that wrong. Make the perpendicular that goes through the point that's off of the line and is perpendicular to the line you drew, just with your hands and your brain and your patty paper. It needs to go through the point that you drew and be perpendicular to the line you've got. You guys are catching on to this fast. There are a few of you talking. No. I think it's probably cheaper than rolls of wax paper, but I'm not sure. Yeah, go to McDonald's and go to your local McDonald's and say, would you like to donate to our elementary school or our junior high or our whatever? Here's how you can do it. No money, just give us a few boxes of patty paper. And they probably go, we don't have any because ours comes all pattied up and it's, no, I don't know. Somebody will have some. They'll probably donate it to you too. Okay. Can you explain it?
Me?
Yeah.
Okay, what I did was, I took the paper and I folded it over and made sure the lines lined up, but it also that the dot was part of the fold.
So how did you get the dot to be the fold?
I was careful to make sure that I saw it there and make sure that the line, I only saw one line.
Does everybody know what she's talking about?
Yeah.
So you roll it until you get the approximately right, and then as you start to pinch, if I got it right there, not roll a little bit more. What? Okay, okay. All right. Now, on the line that you drew, grab your pencil. On the line that you drew, put a point, but don't put the point where the crease meets. Put it somewhere else. Put it away from it a ways. Okay. Now, what I'd like you to do is make the perpendicular line that goes through that point that's perpendicular to the line you drew. So this is the perpendicular through the point on the line. Does that make sense? All right, we've talked about the 2 copies. We've done 4 others. There's how many? Basic constructions? 7, so what's left? Which one haven't we done? The parallel lines. So what I'd like you to do is, with your hands only, I would like you to construct the line parallel to the point, the pencil point you made off of the line, and make it parallel to the line you drew. It's got to be parallel to the line you drew, through the point off of the, is everybody following me? Point that's not on the line you drew. I need a line that goes through that point that's parallel to the line you drew. Parallel. Who can explain how that one works? Yeah.
So you use the 2 creases that you already made that are parallel.
Okay, they're parallel.
They're parallel, the creases are. So you do like what you did before and you match up, when you go to fold it in half, you match up those lines. So
Oh, that's an interesting way to put it. Yeah.
So before, my perpendicular bisector, and you kind of kept going through, so I could also kind of, while I was folding it up, I could also see that those lines matching up, so I could see the 90-degree angle, and then try and make those 2 lines straight. So,
Say it again, please.
so I had the point, I had my line, and as I folded it up to try and increase that line, try to make it even. But before, I had my perpendicular bisector to bring a line to that point, and so I tried to line up those two lines so I could see that right angle. But no, that's shooting, but that helped me.
All right, so you made a perpendicular to the perpendicular, and that made it be parallel. That's one way, that's not the way your compass and straight edge showed you, was it? The traditional way? That's not how they did it, but that's another way to do it. Okay, everybody got their mirrors? Okay, here's what they call a mirror, and they've named it that way because, well, there could be a lot of reasons. One, I can look in here and actually see somebody behind me because it's like it's got reflective qualities, and you might just kind of, you know, get the smudge off just a bit or whatever. But it also has, besides reflective qualities, it has transparent qualities. Okay, the working edge, if you grab your mirror, the working edge is the one that's beveled. You'll find one that's beveled, and it's only beveled on one side. So whenever you're working with the mirror, you always put the working edge down because you're going to have your pencil working against it. And you will always draw on the side that has the bevel on it. The one that goes straight down, that's not where you put your pencil. You put it on the side that has the bevel going in. And I'm not going to tell you why that is. You're going to figure that out in just a bit. All right. Now, you don't need to use patty paper. Just get regular paper. Pull out a blank piece of paper. It can be lined or unlined. What I'd like you to do is, using your straight edge, put a 2 or 3 inch segment on your regular paper. Oh, you're fine. Those are to help it stand up. It works just as good with one. Yeah. It's just somebody's knocked one end of it off. But it'll still work, just the same way, exactly. What I'd like you to do is, using your mirror, your pencil, and your brain, construct. Again, this is not the traditional way, so it's kind of a quasi-construction, although it's just like the patty paper, it's very accurate. I'd like you to figure out how to use the reflective and transparent qualities of this mirror to construct the perpendicular bisector of the segment that you just drew. See if you can figure out how to do it. If you're having trouble, talk to a neighbor. Raise your hand if you have not figured it out yet. Okay, give you another little bit of... The rest of you can, somewhere on that same piece of paper, use your straight edge and make yourself a nice acute angle. Just figure it out. Let me see if I can do it again. Where do you think it might be? Just show me with your finger. Right here, right? So if I'm going to draw my finger there, I'm going to put it right about down there out. Now look and see what you're seeing. Look in the mirror. Mirror on the disc. What is it that you're looking at? Did you see the reflection? Did it match right on top of the two? You draw on the bevel side. Okay. Try and do a angle bisector using the mirror. What do you mean?
You can see the line. Like when I did it.
See if you did it right here. Here doesn't look like it's a box. That really shows it down. the other one, I've got a perpendicular. How do I get it to be, you can see that endpoint is clear up there, and I slide it.